There was a sale, so I went shopping. I found these 43 drawer part trays on sale for 25% off, so I got 4. I saw this rolling adjustable height pneumatic seat, regular $85. I got it for $59. So it's heavy duty, and on the bottom where the footrest would be, it's actually a solid area, and you could actually use it to put things like nuts and bolts if you're working on something. And it doesn't matter if it's open space or not down there, so why not make use of it? These part storage trays are metal, not the cheap plastic ones. And the tops are recessed so you can stack them, and they'll be a lot more stable. Of course, if you're going to stack them, you're probably going to want to bolt them to the wall or whatever, but in the meantime, even just for temporary sitting on top of a workbench, it'll keep them from sliding around off of each other. And this LED shop light, it wasn't on sale. It was at Costco for $48, but they had a demo model turned on, and I liked the amount of light it had. The color temperature is daylight, 5000 Kelvin. So I prefer that over the more yellow lights. It gives a better work environment for me. I know it's really exciting watching somebody put together a stool, so I will spare you. And that's the new stool. Down on the base, it's a metal pan, so you can store loose parts while you're working. And there's a magnetic piece here, so you can just lay screws or washers and they won't get lost. This is a partly finished basement, and this is the far back corner. I set up a buffet table, but there's no chair at all, and there's junk everywhere. So this is where I tested out that old early 2000s era PC recently. But there's no overhead lighting, so I clamped these spotlights temporarily to the joists, but I want to make this more lab friendly. So it's been a couple of minutes. I brought that stool down, and I took away the old ceiling lights, the spotlights, and I installed the LED shop light. So here's the work area with the light off. This is with the only nearby ceiling light installed by the builder of the house. And this is the work area with a shop light. So here's the work surface with regular basement ceiling light, and suddenly you can see. But all this mess needs to get organized now. The end result of trying to get an initial workspace set up, just roughly cleaning up the area, installing the light, and putting a bunch of test equipment and part storage trays on the table, it's ready to go and has sufficient light. So, let's test out the area. Let's do a mini mailbag. Oh, well, it's got what looks like maybe a bunch of surface mount resistors. And what's this? So what have we got? It looks like I ordered 2 sets of potentiometers between 1K and 1 meg. They are typical ones with breadboard friendly pins that can accept a typical knob if you want to put one on there. And I believe they would have been standard linear taper. The resistors, looks like I have about 20 of each. I'm not sure what all the values are, but it's probably a kit covering a lot of common values. I ordered the surface mount resistors just to have around. Sometimes you might need to fix something or work on a proto board. Maybe if I ever do a quick turnaround, cheap PCB manufacturer sort of tryout, I can prototype a little circuit and have some surface mount parts on hand, as opposed to breadboarding everything with through-hole. Potentiometer assortment, 10 pieces of linear pots, 1K, 2K, 5, 10, 100, 500, and 1 meg. $2.65. Robot Maker 2015 sells these. Also from Robot Maker 2015 for $2.84, I got 720 0603 resistors. 36 values from 1 ohm to 10 megs. They are 1% tolerance. And there's a bunch of relatively common values for an assortment kit, so it's not going to contain everything you would need, but just for a standby kit, something good to have around. So I got a lot of loose parts here with the potentiometers. I might as well put them in a part storage tray. According to the writing on this, I have ordered some business and industrial. What is this? These look like flat flex cable PCB connectors, surface mount. There's the 4 pins for the ribbon and 2 solder tabs. And the conductors for the ribbon are on the bottom, so when you plug in the flat flexible cable, you plug it in with the exposed pads facing down for this connector. That gives you flexibility, so for example, if wherever else the ribbon is coming from, the conductors on the cable happen to be facing up, you would buy the connector with the pins on the top of this connector. And to plug it in, it looks like this black part comes out. Then when you insert the cable, you push back in to lock it. Here's the flat cable connectors. You can choose various ones, so I chose 1 millimeter pitch, 4 pins with lower contact, so the flat cable goes in with the conductor facing down to the bottom of the connector. 30 pieces, $2.46 from Superior Buy 2014. I've ordered a few different connectors like this and PCB breakout boards so I can actually solder these up and use them, and I ordered some flat flexible cable. The main reason I bought this stuff is because I have some things coming that have flat flexible cable on them, and I need a way to be able to connect it up and hook it up to 0.1 inch headers or something like that, so I can use DuPont cables and breadboard them. Of course, the ever popular electronic components have arrived. But which components? Oh! Just by chance, here's some of those breakout boards for the flat flex cable connectors. I did not plan this. Okay, I remember these. These are 24-pin cables, and it breaks them out to 0.1 inch headers. So there's 1 millimeter pitch wide connectors on one side, and on the other side 0.5 millimeter finer pitch. So whichever side you populate, pin 1 goes to pin 1 through 24 goes to 24. That definitely makes using those little connectors a lot easier. And I've got more connectors and more breakout boards on order, so by chance it was the 24-pin breakout board I received so far. Quantity of 5 24-pin 1 millimeter pitch and 0.5 millimeter pitch if you flip it over, as they show here, to through-hole adapter from Survey 2014, $2.36. So it converts it to 2.54 millimeter pitch double row headers, which is 0.1 inch of course. And you can use it on a breadboard or a regular PC board 2.54 millimeter header. That makes it a lot easier to use these connectors. This one says speaker module. I have no idea what that means. That's a multi-turn resistor. I'm not sure if this 2W is part of a bigger part number or if it means 2 watts, but it's a 10K plus or minus 5%. I don't know what C plus or minus 0.3% is. I'll have to look it up. The main reason I got this, being multi-turn, if I need to get a really precise value along the 10K ohm range, I can dial it in. So for things like op-amp experiments, this might be very useful if I'm trying to set a set point voltage on a comparator or something like that. The multi-turn pot comes from DIY Box for $1.12. They say it's good from -55 to +100 degrees Celsius, and a lot of other specs that I won't really need to worry about for vibration and torques and forces, but the rated power is 2 watts, and I tried looking up what this C plus or minus 0.3% means. After trying to research what independent linearity means, because it looks like that's what the C plus or minus 0.3% must be referring to on that potentiometer I have, the best info that I can find is this Bourne's technical note about linearity. It's just one page, a quick blurb. I still don't know exactly what it is, but I'm going to try to loosely interpret this. So they're saying linearity is the relationship between the output voltage and the mechanical rotation of the shaft. So I think what that implies is as you rotate the shaft on the pot, intending to change the resistance, you move the shaft a little bit and the resistance will proportionally move a little bit. It's not like having a loose potentiometer shaft where you start turning it and nothing's happening for a bit. It has to kind of kick in and then the resistance starts changing. I think this means you move the pot, you're going to get a move in resistance based on whether it's a linear taper or audio, logarithmic, whatever the curve is. Your intentions of changing the resistance on that curve are going to tightly follow your movement of the shaft. So they say independent linearity is the maximum permissible deviation of the output curve from your reference line. Again, if it's a linear taper, this red line is diagonal, so as you move the wiper, your resistance will go up or down relatively in a straight line. And it looks like this purple line is the plus or minus 0.3% difference in translating your attempt at moving the pot and changing the output resistance by that much of a movement of the pot. I am only guessing, I don't know for sure, but that's what this looks like it would mean to me. It's basically how tight is the pot shaft and how responsive is it for what you're trying to accomplish by rotating it a bit to change the resistance. If I'm way off and anyone knows what this actually means, or if I'm right, let us all know in the comments below. This is news to me. I've never heard of this term before. I don't really need to know this for what I'm using this for. It's just bench testing, so it's good to know there's info to learn out there. Potentiometers aren't just 3 terminal devices that you slide the pot or turn the pot and get the output resistance. There's a lot more specs to it. Always good to learn new things. So that's it for this one, and I'm glad I have a lot more of a reasonable workspace.